Now, welcome back. Ang pag-uusapan naman natin ngayon ay determinacy and stability of structures. For the determinacy, when all the forces in structure can be determined from equations of equilibrium, the structure is referred to as statically determinate. So, meaning, if the number of reaction is just equal to 3n, that is statically determinate. Structure having more unknown forces than available equations of equilibrium called statically indeterminate. In that case, if the reaction is greater than 3n. So where n is the total parts of the structure members, where r is equal to the total number of unknown reactive force and moment components. So let us take this example. Classify each of the beams shown below as statically determinate or statically indeterminate. If statically indeterminate, report the number of degrees of indeterminacy. The beams are subjected to external loadings that are assumed to be known and can act anywhere on the beams. Okay, isa-isahin natin. For this structure, so in here, since we have a pin support, meron tayong dalawang reaction. And this is a roller, so meron tayong isang reaction perpendicular to the point of contact. So, R is equal to 3 and N is equal to 1 since we only have one member here. So, check natin if since R, if this is equal to 3n, therefore it is statically determinate. So r is 3, that is equal to 3 times 1, 3 is equal to 3, so meaning this is statically determinate. Next, so in this point, we have a fixed support, meaning we have 3 reactions here. And then here, you have 1 reaction, roller, 1 reaction. So the total number of reactions is equal to 5. And your n is equal to 1. It's a relationship between R and the 3n. So R is 5 and this is 3 times 1. So 5 and this is 3. So meaning 5 is greater than 3. So makikita natin dito that this is statically indeterminate. Now, kung makikita natin, since 5 is greater than 3, yung difference, no? So 5 minus 3 is equal to 2. This is referred to as the degree of indeterminacy. So this is statically indeterminate to the second degree. Okay. Kung makikita natin dito, we have 2 members. Isa-separate natin yung 2 members para ma-expose natin yung reaction natin dito sa internal hinge. So, for the reactions, we have here a slider. So, slider, meron tayong dalawang reaction. So, sa hinge, we have 2 reactions. Kukontrahin lang natin yun dito. And we have here a hinge also. So, dalawa dito. We have 2 here. Ang bilang po natin nito ay, no, pag nabilang na natin siya doon, the same lang naman yun siya dito. Isang beses lang natin siyang bibilangin. So, this is just 2. And here, this is 2. Now, kung makikita natin, we have n is equal to 2 since we have 2 members here. And for the reactions, we have total of 6. For the relationship of the reaction to 3n, so we can say that 6, and this is 3 times 2, 6 is equal to 6. So this is statically determinate. Okay. So, ang gagawin natin dito ay isolate ulit natin yung mga members natin. Kung i-isolate natin yung mga members natin, so we can see here our reactions. Dito, we have a fixed support. So, meron tayong tatlong reactions dito. This is a hinge, and we have two here. Kukontrahin lang natin yung direction na inassume natin. And another two here. So, kukontrahin ulit natin yung directions na inassume natin. So, this is a fixed support. Meron tayong tatlong reaction. So, we have here 3, 2 here, 2 here, and 3 here. So, for the number of members, so n is equal to 3, and for the reaction, that is equal to 10. So, to solve natin yung relationship between the r and the 3n, we have r and the 3n. So, r is equal to 10. 3 times 3, so 10 is greater than 9. So, this is greater than. So, meaning this is statically indeterminate. 10 minus 9, so that's 1 to the first degree. Example number 2, classify each of the pin-connected structures shown in the figure below as statically determinate or statically indeterminate. If statically indeterminate, report the number of degrees of indeterminacy. The beams are subjected to external loadings that are assumed to be known and can act anywhere on the beams. Okay, so isa-isahin natin siya. I-isolate natin yung mga members natin since we have here an internal hinge. So, ito yung isa and ito yung isa. Okay. So, for the number of reactions dito, this is a fixed support. So, we have here 3 reactions, horizontal, a vertical, and a moment. In here, we have an internal hinge. So, we have a vertical reaction and horizontal reaction. And ito din yun. And here, this is a hinge. So, we have here a horizontal and a vertical reaction. So, tatlo yung reaction natin dyan, dalawa yung reaction natin dito, and dalawa yung reaction natin dito. Solving for the relationship of the R to the 3N, we have the number of reactions equal to 7, and your N is equal to 2. So, this is 1, this is 2. So, 7 is greater than 6. So, since 7 is greater than 6, so we can say that this is statically indeterminate to the 7 minus 6, 1, so that's first degree. Okay, next. If we are going to isolate the members, so we have here this vertical member and the horizontal member and another vertical member. So for the reactions, since medyo naka-incline diyan, so meron tayong dalawang reactions dyan. And in here, we have 2 reactions sa internal hinge. Kukontrahin lang natin yung in-assume nating direction. And ito yon. So we have here this reaction. And in here, meron tayong tatlong reaction because this is fixed. So, dalawa dito, we have 2 here, and we have 3 here. Solving for the relationship of, so the number of members, we have 1, 2, 3. So, R and the 3N. So, our reaction is equal to 9 and N is equal to 3. So, solving for the relationship of the R to the 3N. So, this is 9, 3 times 3. 9 is equal to 9. Meaning this is statically determinate. Okay. So, kung i-isolate naman natin itong mga members na to, so we have this. Ayan. So, for the reactions, dito, we have fixed support. So, meron tayo ditong tatlong reaction. And then here, we have 2 reactions. And then here, this is fixed support. So, meron tayo ditong tatlong reaction. And this is a hinge. So, meron tayo ditong dalawang reaction. So, tatlo dito, dalawa dito. We have 3 here and we have 2 here. So, for the number of members naman, so we have 1, 2. So, your N is equal to 2 and reaction is equal to 10. So, solving for the relationship of the R to the 3N, so we have 10, 3 times 2, so 10, and this is 6. This is greater than. 10 is greater than 6 by 4. So, this is statically indeterminate to the 4th degree. Okay, so kung i-isolate natin to, so we have here, so we have 3 members here, 1, 2, and 3. Makikita natin dito that we have a smooth pin connected collar. And for that, we have one unknown. The reaction is a force that acts perpendicular to the surface at the point of contact. So we have one reaction here. And in here, if you have a roller, so meron kang isang reaction dyan. This is an internal hinge. So meron kang dalawang reaction. And kukontrahin natin yan siya dito. Another internal hinge here. So, yan yung reaction natin. And take natin yung opposite directions ng assumed reaction natin at that point. And here, meron tayong tatlong reactions. So, we have, for this member, so we have 1 here, 1 here, 2 here, 2 here, and 3 here. For the number of members, your N is equal to 3 and the reaction is equal to 9. So, solving for the relationship of the R to the 3N, so R is equal to 9 and 3 times 3, this is 9, is equal to, so this is 9 is equal to 9. So, meaning this is statically determinate. Example number 3, classify each of the frames shown in the figure below as statically determinate or statically indeterminate. If statically indeterminate, report the number of degrees of indeterminacy. The frames are subjected to external loadings that are assumed to be known and can act anywhere on the frames. So, isa-isahin natin siya. So, hatiin natin yung ating frames into two parts, and we have so the number of members, so we have 1, 2, and for the number of reactions, we have here 2. So dito, since this is fixed support, kung babalikan natin yung idea ng internal loading, so meron tayo ditong tatlo, and then here take lang natin yung opposite para dito. So dito meron din tayong tatlo, and dito sa kabila, we have a roller, so we have one reaction here. So we have 2 here, we have 3 here, we have 3 here, and 1 here. So n is equal to 2, and the reaction is equal to 9. So for the relationship of the r to the 3n, so we have 9, 3 times 2, 9 is greater than 6. So this is statically indeterminate to the 9 minus 6, that is third degree. Okay. So if we are going to divide this frame, so meron tayong so if we are going to divide this frame, then we have okay, so for the reactions, dito we have a roller, so we have one reaction here. This is a fixed support, so we have 3 reactions here, and this is fixed, so internal loading, and tayo ditong tatlo. This is internal loading, so meron tayo ditong tatlo, and dito this is fixed, so meron tayo ditong tatlo, and then here this is a hinge, so meron tayo ditong dalawa. So we have 1 here, 3 here, 3 here, we have 3 here, 3 here, and 2 here. So for the total number of members, so we have 1, 2, 3, so your n is equal to 3. So for the total number of reactions, your r is equal to 15. So checking for the relationship between the r and the 3n, so r is 15, this is 3 times 3, 15 is greater than 9. So meaning this is statically indeterminate. So 15 minus 9, that would give us 6 to the 6th degree. For the stability, so to ensure the equilibrium of the structure or its member, it is not only necessary to satisfy the equations of the equilibrium, but the members must also be properly held or constrained by their supports regardless of how the structure is loaded. Two situations may occur when the conditions for proper constraint have not been met. So we have the partial constraints and the improper constraints. So what is a partial constraint? Instability can occur in a structure or one of its members has fewer reactive forces than equations of equilibrium that must be satisfied. The structures then becomes only partially constrained. For example, consider the member shown in the figure. Kung makikita natin dito, we have reaction FA here perpendicular to the point of contact and a moment here. But we have the load P here. So si load P ay merong vertical component at merong horizontal component. Ngayon kung titingnan natin, if we are going to check the summation of the forces horizontal must be equal to 0. Therefore, the summation of the forces horizontal is equal to 0 will not be satisfied for the loading condition, and therefore this member can be considered as unstable. For the improper constraints naman, in some cases there may be as many unknown forces as there are in the equations of equilibrium. However, instability or movement of the structure or its member can be developed because of improper constraining by the supports. This can occur if all the support reactions are concurrent at the point. So kung makikita natin dito, yung reactions natin at point A, at point B, and at point C is concurrent at point O. So since concurrent yung mga reactions, therefore, so from the free body diagram of the beam, it is seen that the summation of the moments about point O will not be equal to 0. No? So kasi kung magsusumate tayo dito ng moment natin sa point O, that would not be equal to 0 because here, makikita natin na mayroong moment to be created by the force. So since the moment PD is not equal to 0, thus the rotation about the point O will take place. So iikot itong system na to dahil dito kay moment created by the point P. Another way in which improper constraining leads to instability occurs when the reactive forces are parallel. So kung makikita natin dito, parallel yung reactions natin dito kay point A, kay point B, at kay point C. Now, if we are going to summate forces horizontal, that would not be equal to 0. Kasi makikita natin dito that our P has the horizontal component. Example number 4, classify each structure in the figure below as stable or unstable. The structures are subjected to arbitrary external loads that are assumed to be known. So, classify each of the structures in the figure below as stable or unstable. The structures are subjected to arbitrary external loads that are assumed to be known. Okay, so for this, kung titingnan natin, we have two reactions. Isa dito and isa dito, and here we have one reaction. So for this, check muna natin yung ating determinacy. If we are going to check for the determinacy, your n is equal to 1 and the reaction is equal to 3, so we can say that 3 is just equal to 3 times 1 because 3 is equal to 3. So this is statically determinate. And for the stability, kung titingnan natin dito, yung mga forces na to is not concurrent. So, although kung titingnan natin dito, magiging concurrent, no? Si AY at saka si BX. Pero si AX ay hindi naman pupunta sa point na to. So, therefore, there is no concurrent reaction. And the reactions are not parallel. So, therefore, this is stable. Okay, so another example here. Gagawin natin ay i-isolate muna natin yung member. So, i-isolate natin yung mga members and we have two members here. So, for the reactions, we have 3 reactions at point A kasi yan ay fixed. So, we have 3 here. And sa internal hinge, we have 2. And sa point B, we have 3. So for the number of members, we have n is equal to 2, and the reactions, meron tayong tatlo dito, we have 2 here, and we have 3 here. So we have a total of 8 reactions. So checking for the relationship of R to 3n, so R is equal to 8. So this is 3 times 2, 8, and this is 6. So 8 is greater than 6 by 2. So meaning this is statically indeterminate to the second degree because 8 minus 6 is equal to 2. So para naman sa stability, hindi concurrent yung mga reactions natin, and hindi rin parallel yung mga reactions natin. So therefore, we can say that this is stable. Okay. So for this structure, so we have 3 reactions here. One reaction for this roller, another one reaction for this roller, and another one reaction for this roller. So your N is equal to 1, and the reaction is equal to 3. So 3 is just equal to 3 times 1. 3 is equal to 3. This is statically determinate. So check natin for the stability, since yung mga reactions natin are parallel, so meaning this is unstable. For this, makikita natin that we have one reaction here at the roller, and we have 2 reactions here at point B. So since they are concurrent sa point na to, meaning that is unstable. Kung i-check natin yung determinacy natin, and that would give us n is equal to 1 and r is equal to 3. So 3 is equal to 3, meaning this is statically determinate. And last, so ang gagawin natin dito, isolate muna natin yung mga members. So this is for the member AB, this is for the member BC, and this is for the member CD. So at point A, we have one reaction. Since this is a roller, we have internal hinge here, 2 reactions, and then here you have 2 reactions, and at point D you also have 2 reactions. So we have 1 reaction here, 2 reaction here, you have 2 reactions here, and 2 reactions here. So for the total number of reaction, R is equal to 7, and your N is equal to 3. So checking for the relationship of the R to the 3N, so we have 7, and this is 3 times 3, 7, and this is 9. So since 7 is less than 9, this is unstable. So wala tayo ditong determinacy kasi as you recall, if R is equal to 3N, that is statically determinate. If R is greater than 3N, this is statically indeterminate. And if R is less than 3N, this is unstable. So, kailan lang tayo nagkakaroon ng determinacy? Nagkakaroon lang tayo ng determinacy if R is greater than or equal to 3N. So, if we have this condition, R is greater than or equal to 3N, then we have to check if the structure is stable or unstable. But if it is less than 3N, then automatic unstable siya.